Okay, now we're going to do part 2 of the switch tutorial, making a software switch and connecting to physical devices. So I made some processing code there, and we were just using the keyboard. Now let's do a physical switch in Arduino. Basically, let's see, do I still have this? Basically, the button is this from the add fruit digital inputs. Sorry. I edited this out. Oh, well, that's all right. So it's this one, lesson 6 from Adafruit. And I've sort of modified this code, but if you look at the breadboard layout, they do a kind of nifty trick where all they do is a digital output and a ground. They connect a switch, one side of the switch to a digital output, and the other side of the switch to ground. And they use the internal resistors. Okay, so you can look at that, but that's how I set up my my switch, and I just sort of ignore the rest of this because we're just using the switch. Eventually, maybe we can add LEDs. We'll see. Okay, so basically, first of all, before I do any of the physical computing stuff, I can copy over all of the. I can copy over all of the code pre-button. Well, just to explain, here in my processing code, I use the key pressed, so any key depressed. So basically, our physical button, our switch press button, is just going to replace this code. So everything else is just, the code will remain the same. So I can just go ahead and copy all this over and paste that in there. And then I can also do the stuff in draw while in loop, really. Okay, so I'll just go ahead and copy all that over as well. So everything in draw is going to now go into loop. Okay, and now the main thing we have to do in Arduino is just replace this business in here. So the physical switch readings, the keyboard is going to be replaced with the physical switch readings. And I've sort of adapted the code. So let's go ahead and do that. So what we need is an integer that represents the port, the input port of our Arduino. So we're going to use, in this case, I happen to have my switch plugged into a digital input 7 or digital port 7. I'm just calling it B1. And we'll go ahead and do a serial begin. I can type this stuff. And we'll have it at 9600 baud rate. Okay. And we're going to set the internal resistor input pull-up. I guess just trust me on this. You can read more if you want. PIN mode for B1 is going to be all caps input pull-up. Okay, it's going to pull the resistor up. All right, and then I always like to have an extra value here. I don't know why I put it out there in setup. Oops. Int B1 val. And we're going to make that equal to 0 for now. All right. Okay. Now, so basically, we're going to do this business here. Gate 1 equals true and gate 1 equals false using our switch. So we'll do that first. Well, yeah, the very first thing. So we're going to say if the digital read of B1 is equal to low. Okay, that's when the button's pushed down. Then basically it's just going to take the place of our switch. And if we go here, it's going to gate 1 is equal to true. Okay. And the rest of the state stays the same. Okay. And what we can do is we can do an else if we want, or just to be more explicit, if digital read of the button 1 is equal to high, then we'll go gate 1 equals false. Okay, and for all this business down here, you just should go ahead and look at the other previous tutorial, and it explains all this, how we create a switch that only gives one indicator. So the main thing we have to change here, though, is we have to make it serial print then. So print line, we're going to print to the serial. We're going to say serial print, dot print, and then we'll just go on. Let's go print line and serial dot print line off. Okay. Oopsie. Oops, what happened here? I think I added too many things or something. Oh well. Seems to be some error in our auto tabbing. Everything seems to line up okay. Yep. Void loop. Okay, well, we'll give it a try and see what happens. All right. So let's just check our code. Oops. Ah, yeah. Well. Void loop. Ah, I see. Void setup is okay. Void loop. Keep true. Ah. I always do that. I always forget the quote. Now everything should be great and grand and dandy. Okay. Oops. Have to correct this here as well. Okay, let's compile that. Great. Now we'll push it to Arduino. And like I said, I already have my Arduino all set up with a switch. And let's have the serial monitor. And if I push the switch, it should be on one time. If I let go of the switch, off one time. And it gives me the count. If I push the switch on, off. Oh, we got a little too many there. Somehow, I think I messed with the wires a little bit. On, off 4, on, off 5, on, off. So that works brilliantly. Okay, so it's just now with this code there, you get a one-time only switch using a physical switch, and you send it to. Okay, so great. So that's fantastic. It works well. It worked great in processing. Hopefully you understand it, how these things work. It seems a little bit complicated, but it's not really. You just need a kind of number of iterations of this kind of gate situation. So basically you need a gate to allow you to use the switch, and if the switch is true, then it automatically turns it false, so it doesn't do it again. And this gate is controlled by the actual physical switch, so you can open the gate or you can close the gate depending on if you're pushing the button or letting go of the button. And here is the kind of important part. It's toggling through or through a certain amount of numbers. Okay, so let's go ahead and prepare this now. The next step is really to prepare this now for use with our Supercollider code that we had gone over earlier. And what we'll do is we'll have now, we're going to just print, not print line, but we're going to print some sort of header, and I'm just going to put in quotes SW1 with a colon. So that'll be our header. It's going to print the increment it's on, so 0 through 5, and then it's going to print a semicolon in quotes. Okay, and this we can do just print line. All right, and that's going to send a nice message to our Supercollider that looks like this: SW1 with the increment and a semicolon after that. Okay, so let's go ahead and we'll save that, load that to our Arduino board. and look at the serial monitor. And so if I have it pushed, it'll do it on release, remember. So every time I release it. Great. Fantastic. Okay, well, let's grab that Supercollider code, GitHub, on my GitHub page. Repositories, and we'll grab this Arduino to Supercollider. Go ahead and download the zip. Okay. That should put me somewhere. Okay. All right. So we'll go ahead and list our devices, and we'll grab that one there. Pop that, make sure it's the correct device. Well, it happens to be the same one. And great, we'll boot the server, and we'll start up our Arduino SMS. Okay, and let's grab a switch one. So I'll just copy this code here. And since we already have all these, I'll go ahead and just put it below that and call this the switch. Oh, this is really small, isn't it? Let's make this huge. Okay, so we'll call it switch 1. Okay, and what did I call it here in the Arduino code? I called it SW1. Okay, so is it lowercase? Sorry. Yeah, lowercase, SW1. So if the header is SW1, then we're going to KBS 6. I'm going to go KBS 6 and set, and it'll be data split. I'm going to do as integer. Okay. Okay. Now, well, that will toggle between different kind of things, and we can actually, why don't we just print this, post this, because we're actually going to do something a little bit different with it. So we'll just post it right now. Okay, and we'll evaluate that code. Hopefully it's grabbing it. There it goes, right down here. You can see the 3, 4, 5, 6, or 1, 0, 1, 2, 3, 4, 5. That's perfect. Okay, so in this part now, so we're getting into our Supercollider. That's very nice. In this part now, we can do a number of different things. But what I'm going to basically do is I'm going to set an integer, a variable, and then I'll use that variable to switch. Okay, we'll make an actual software switch as well. So let's go all the way up here and create a variable. So we're going to make a variable outside of our action. This is every time an action happens from the serial bus. We get a message or something, and then it performs all this action. So we're going to put it outside that action. We're going to make another variable here, and we're going to call it SW1, maybe tog, this one, or val, if you want. And we'll make that equal to 0. Okay, so that's when we initially evaluate it. Okay, and then so we don't need this anymore. And we can set the control bus if we want to, but in this case, in other words, one thing you can do, if you remember, is you can set a control bus to these values, and then later on grab that. So that could be useful for a lot of different things. But let's say in this instance we want to actually switch, say, between different effects or something like that, or different synth defs, that sort of thing. Okay, so let me show you how to use just a software switch, or just the control structure switch. So we don't actually need that either. But instead, what we're going to do is we're going to set that variable, which was SW1 val, okay, it's going to equal this, the data split 1 dot as integer. Okay. And then, so this happens every time an action from Arduino or something comes in from the serial bus, and every time it equals this, right? So we're going to set that val as an integer, and then we're going to use a switch. And so we're going to do switch. Okay, and it's going to be SW1 val. So you can look at this by doing Command D there, and it'll show you control structure. And so, for example, you see you switch, and then it's the thing that you're switching on, and then the options. So if that switch happens to be 1, then you run this. If it happens to be 1.1, you run that. Okay. So we'll do something like that. Switch 1 val, have a comma there, and then we're going to have 0 through 6. And then we'll have that option. 1 will be that option, etc., etc. So if we copy those, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and we don't need this comma here. Okay. So those are our options. So for example, let's see. Let's just do some very simple synth-defs here. I'm just going to throw some things together. I'll just do a very quick synth-def here. And again, these will be your own sort of processing, your own things that you'll fill in. I'm just going to put some placeholders in there. And this will be T1. Dot add. Okay, and we can have just a simple out. And then this will be 0, and this will be sign os. Okay, and then we can have a T2. We can do saw. Okay, and a T3. Just to give you an example. Saw, and this could be, let's do pulse. Okay, so if we have those three, T2, T1, T2, T3, okay. So basically what we can do is we can have each of these, each time we can toggle between the, well, there's 6 of them, but let's just, well, we'll just fill 3 of them. We'll just do 3 and 3. We can toggle between the sine wave, the saw, and the pulse wave, something like that. Now, one of the problems here, well, not the problems, one of the issues is you want to start a synth and then you want to kill that synth and start another synth, right? Okay, so what we can do is we can have some specific synths here. So we can have, for example, so if this is going to be, if this is going to be, we'll use, there's a number of ways to do this, I guess. That's the hold up here. But let's just use global variables just to keep things simple. So if we have S1, a synth, okay, and we're going to say it equals to synth, okay, and it's going to be T1, right? Okay. In this case, the next one, when it toggles to the next one, we're going to kill S1. So S1.free is going to be the first thing it does. And then we'll say S2 equals synth T2. Okay, that guarantees that each time you toggle, it'll kill the previous one. Copy. And then this will be S2 free. And S3 equals T3. Oops. And then we'll just repeat them. S3 free. S4 equals T1. Oops. S4 free, and S5 equals T2, and S5 free, and S6 equals T3. And then, of course, we're going to have to free the previous synth here. So we're going to free S6, sorry. All right. So let's give that a shot. Let's see what happens. Well, it's not too loud. Do we boot the server? Yeah, I think it's all booted. So if I engage there, I should have that. Okay, great, it works. Okay, so then you see how we can use the switch here now in our data split. Well, let's go ahead and show what's coming out as well. So we'll do that. Oh, I think I need to do I need to redo it? Well, let's see what happens. Okay, and so 1 is the 2 there is the pulse, 3 is the sine, 4 saw, 5 pulse again. Okay. And let's have, why don't we have, instead of 5 being pulse again, let's just kill it all together so we can have some peace. We can have it off. So instead of bringing that on, we'll just have an S5 free. And then we can, this can be, we don't need this because there's no S6. So let's try that. And then, so 0 turns it on. That's the saw, that's the pulse, sine, saw, pulse, and then off. And then back to that. Okay, so this just gives you a brief idea of how then now you can toggle between different, so it could be processing effects, it could be different synths and stuff, and you can use that physical switch. And you're actually sending yourself messages here from Arduino in this way. And that's kind of a handy toggle. And of course, keep in mind, remember that if you want to change the total number of toggles, you change that SW1 total. And it's easy. I mean, I hope you can see how it would be easy enough to add multiple switches to do different things. You just call it SW2 and you send an SW2 here. You create another switch. And of course, you can have it toggle through as many things as you want. So there you go. Hopefully that's useful and helpful to be able to use a physical switch to toggle things.